welcome, um, all these fellow interested people in the rivers in our backyard. I am Donna, part of the sustainable community of King County North, sponsored by the Bahá'ís of the King County North. And we have been anxiously waiting for Matt uh, Bearwald to give us this little lecture on the river. He is well renowned in the nation of Snoqualmie tribe. He is an environmental policy analyst for the tribe in their Environmental and Natural Resources Department. Matt Bearwald will share the results of the Snoqualmie River study, which we've been anxiously waiting for. The presentation is an overview of the Snoqualmie tribe's Upper Snoqualmie River Resilient Corridor Management Plan. This plan is an all-purpose document for multiple audiences intending to serve as a knowledge source and tool across the communities to support a richer cultural relationship with the Snoqualmie River and to promote a collective understanding of the resilient river for all of us. It shares what was heard from the community and the results of the scientific assessment, as well as the communicates to the river and city managers, specifically King County and the city of Snoqualmie, since they own and manage much of the land along the upper Snoqualmie River, that a more responsible approach is needed to respond to the constantly changing river environment. The people of the Snoqualmie tribe are the original stewards and the protectors of this land, and the tribe knows the landscape needs attention. This plan continues the tribe's work in the region and shares a resilient river vision, recommendations for all. And we'd like to, at this time, pay respect to the Snoqualmie tribe and all nations of our indigenous people. We respectfully acknowledge that they are on, and we are on the ancestral land of the Snoqualmie people, whose presence here has been since the time immemorial. Matt, you're so kind to present this talk for us and patient with us, constantly seeing how you were doing on that most important plan that you and the tribe and your community have developed. So I give you the forum at this point, and thanks again.
Well, thank you, Donna. Thank you for that detailed introduction. And yeah, I'm happy to be here today, and I'm glad you all are here, able to join us and hear about this body of work. That this is really just sort of the beginning, I hope, of the start of a conversation. And yeah, I really appreciate that introduction. So I'm Matt Bearwald, as Donna said, the environmental policy analyst for the tribe. I've worked for the tribe since 2008. I'm not a tribal member. I'm a tribal employee in the Environmental and Natural Resources Department, and really honored to have had the opportunity to work in that department for such a long time, and to work on really, work that's so important, like with this that I'm going to be presenting on. And so yeah, folks were asking about my background, my I guess my personal background. I'm a conservation biologist by training and education. My Zoom background is a picture of a Wapato patch in the lower Snoqualmie Valley. It's on private property currently, but Wapato was a really important native ancestral food for the Snoqualmie people and many other Coast Salish peoples. But it's a tuber. It's a wetland plant, and the tuber, kind of like a the plant itself might resemble like a water lily in a way, but they also call it arrow leaf. It has kind of a arrow shaped leaf, and the tuber is harvested. And I've had a chance to try it. It was kind of like a cross between a water chestnut and maybe a little radishy and a potato, like somewhere in there. So I'm going to share screen. So thanks again for the introduction, Donna. If y'all end up hearing a little bit of redundant language, that's because that intro is kind of harvested from this presentation and other communication materials for this work. But today I'm going to be presenting on, and really, like I mentioned, I hope that this is the start of a community-wide conversation about a project to create the Upper Snoqualmie Resilient River Corridor Management Plan. And this is a project that was funded by a grant received from the U.S. Bureau of Reclamation for just under $200,000. And that grant funded the project research, outreach with the community, and ultimately the development of the plan. The final plan will focus on understanding, or it does focus on understanding, protecting, and conserving water quality and quantity for the Snoqualmie River Valley as a whole, but it focuses in on the Upper Snoqualmie River specifically. And the plan and the overall project were conceived of to fill what we identified as a need for a cohesive, holistic strategy for this important area. It's something that didn't exist previously, and the tribe is the best group to take on this challenge. I don't know if y'all do chat, like Zoom chat questions, but I'm not gonna monitor those while we're going. So I'm happy to have a conversation, and if you find a pause and you have a question, you can interrupt me. Otherwise, I'm happy to answer questions at the end. But today I'm going to cover these 4 items. First, we'll go over our outreach process. We're going to talk about how data was collected, how the Resilient River Corridor Plan was drafted, and finally, the outcomes of this plan and what I hope to see as a result. For our outreach process, the Snoqualmie Tribe's Environmental and Natural Resources Department engaged with the tribal community and the community at large to gather stories about how people connect to the river, how they see changes, and how they feel about changes happening to the Upper Snoqualmie River Valley. We conducted a survey and small group interviews. We received back 61 online surveys, 13 paper surveys, and 17 tribal member survey responses. We conducted a listening session with the culture department. Some of the top interests for the 74 total survey responders included the flow rate of the Snoqualmie River. People were concerned about flooding affecting their homes and communities, as well as climate change. Survey responders worried about development and want to minimize development in the floodplain. People are interested in increasing the riparian buffer around the river, and they want to use this open space area for public access while also allowing for natural river processes like the shifting of the river channel. There's a shared concern to preserve and care for the river, and people also were thinking about the possibility of less water available in the future and how that might impact fish and wildlife, as well as that relation to the timing of flows in the river. And so what we found with this and what we heard back is that the community knowledge and their concerns greatly align with and reflect the conclusions of our project data. So the findings reinforce the recommendations made at the end of our plan for resiliency. The next few slides, I'm going to summarize experiences from tribal members and Snoqualmie Cultural Department staff, and propose recommendations for how to increase access in 3 areas: the Snoqualmie River, the River Valley, and Snoqualmie Falls. The Snoqualmie tribe asserts that tribal community access is an integral part of a resilient river corridor. And there's an obvious connection here to the ancestral lands movement, which seeks to spread awareness of the Snoqualmie people who have lived in the southern Salish Sea region since time immemorial, and share the significance of these lands and provide information on how people can help the tribe in respecting, restoring, and protecting these lands. What we heard back from the community reinforces the Snoqualmie tribe's ancestral lands movement. For example, that these lands have been heavily impacted by recreation, water quality is declining, and the Snoqualmie River is experienced as having a lot of litter and trash. For access in the Snoqualmie River Valley, stewardship and restoration of nearby accessible locations to harvest ancestral and local foods and materials has been brought up as a desirable component and action of a resilient river corridor planning process. So signage installed in these areas acknowledging the tribal connections would help to combat the current erasure of the Snoqualmie tribe's management and relationship with the river since time immemorial. We documented a cultural conflict between tribal rights to clean water and food and having to pay or negotiate with private landowners to exercise those rights. Access to more pristine, productive, and private harvest locations, for example, upstream in the Middle Fork or North Fork Snoqualmie watersheds, they often require passes from landowner timber companies or even from the federal or state government. And tribal members observe that many local wild foods seem to be decreasing in abundance and availability. Some of those that they gave as examples include salmon, clams, which are how the tribal community refers to the freshwater mussels that are present in our streams and wetlands, steelhead, and wapato, which I mentioned wapato earlier. For Snoqualmie Falls access, we found that tribal access to the river is a challenge here, and it's currently limited to public boat launch areas at some parks and the gated area at the bottom of the falls. The falls are accessible by tribal members, but requires a key to access the gated area. And this can be a barrier as not all tribal members may be aware of the access process. The other side of the falls is only accessible by purchasing access through the Snoqualmie Falls Forest Theater property. So increasing access for the tribal community to the falls is another outcome supported in the plan. For our research and data collection, this consisted of reviewing existing data, fieldwork, new fieldwork, and hydraulic modeling. A technical team of scientists assessed the current state of natural river and floodplain processes in the project reach and how these processes affect water quality, water quantity, floodplain function, and in-stream aquatic habitat. We identified new areas for fieldwork. Those include corridor forest health, channel and sediment dynamics, floodplain connectivity, and revetments or bank armoring and wood recruitment. Our team completed hydraulic modeling. I have to thank and acknowledge King County for sharing their hydraulic model with us. Our work included climate change analysis, which is another layer detailed in the plan. We assessed how the conditions and processes of the river are expected to adjust in a changing climate. For drafting the Resilient River Corridor Plan, the results of the hydraulic assessment indicate that floodplain connectivity varies throughout the planning area and that flood risk through the city of Snoqualmie is expected to increase under climate change conditions. As a result of a recent lack of a cohesive, long-term management approach, the upper Snoqualmie River Valley is currently a disorganized, broken landscape. And this plan is intended as a conversation starter. The Resilient River Corridor Management Plan proposes 22 recommendations for restoration and activities to reconnect the floodplain along the different reaches of the planning area. We want it to serve as a community knowledge source and a discussion tool, and to support that, the plan invites others into the process. And we hope that it promotes a collective understanding of a resilient river for all. This plan reports back what was heard from the community and the results of the scientific assessment. I've said a bunch of times, I think, it's a conversation starter. It's intended to communicate to river and city managers, specifically King County and the city of Snoqualmie, since they have management responsibility for much of the land along the river, that a more responsible approach is needed in order to respond to the constantly changing river environment. We found that the upper Snoqualmie has faced systematic impediments to resilient investments in the river corridor. This is, at least in some part, arguably in a large part, due to a strong regional focus on and a prioritization of funding the types of river restoration projects that are needed, but funding those in direct salmon habitat, which of course above the falls is not direct salmon habitat. But it turns out that conditions in the upper Snoqualmie and in the project area in particular are directly contributing to continued impairments in the salmon habitat downstream. And the people of the Snoqualmie tribe are the original stewards and protectors of this land, and the tribe knows the landscape needs attention. So the Snoqualmie tribe will continue the restoration and management activities as it always has, and will lead the call for change in the river valley. And so to that end, we produced 22 recommendations to increase resiliency. They range from low cost to high cost activities. There are clear areas of overlap between sacred places and areas planned for urban growth, where good relationships and respectful land and water use management decisions will sustain the long-term health of the river and all residents of the upper Snoqualmie Valley. The Snoqualmie tribe asserts that tribal community access to the river and floodplain is an integral part of a resilient river corridor. In order to organize our plan, we divided the project area into 4 reaches. And so this map depicts those, extending from upstream to downstream, upstream being at the right or east end of your map. That we've got the Confluence Reach, the Kimball Creek Reach, the Meadowbrook Slough Reach, and the City Reach. And so I guess I want to preface that this is kind of the part of the presentation where it starts to get a little more technical and detailed. And I know that, yeah, well, actually, I don't know much about my audience, and some of you may have a lot of technical experience, and some of you may not. So the plan itself goes into, works to explain in more detail some of the concepts. Some of the things that I mentioned may be, I may not give all the background behind them, but I'm happy to discuss more. So many of our reach scale recommendations focus on reconnecting the floodplain. And this slide highlights the Three Forks Reach. We found that the channel in this reach is over widened as a result of a highly depositional sediment regime. And there's a lack of a robust riparian forest to slow the channel widening. That would help to create hard points in the river system where forested islands can develop. Groundwater gradients inferred from summer water surface elevations indicate a primarily down valley flow with some flow into the channels from the floodplain. So in other words, the stream flow or the river here is gaining from groundwater. So groundwater in this area is putting water into the river. That's not always the case everywhere across every part of the landscape. There are portions of the landscape where rivers can be losing reaches, where actually rivers are putting water into the groundwater. So in this reach, again, it's stream flow is gaining from groundwater. Stream temperature in this area is elevated. The Middle Fork and the Three Forks and the Upper Snoqualmie contributes 50 to 60% of the main stem Snoqualmie flow in the summer season. And the Middle Fork temperatures are elevated 2 to 4 degrees Celsius above flows from the North Fork and South Fork. And that's also elevated, it turns out, above main stem temperatures at the downstream end of our project reach near the falls. So in this reach here, coming out of the Middle Fork, the water is really warm, but then there are some contributors, kind of foreshadowing later in the presentation, where there are cooling elements, and it actually water cools in the downstream direction, which is not the general pattern overall across the landscape. Usually water flowing downstream, and at least in the summertime, most of the time, it usually is warmer in the downstream direction. So the riverbank revetments are bank armoring in this reach are primarily along the right bank. Right bank of a river is when you're looking downstream. So that'd be the north on here. They're along the right bank, protecting the road and near the bridge along the North Fork Snoqualmie. And so in this reach, the road, I think you can see my cursor, is built. It's built along the toe of the hill slope, into which the river would not typically have widened into the toe of the hill slope. So it's unlikely that the hardening, the bank hardening that's occurred there, it's unlikely that that's been in response to widening. That's occurred almost exclusively along the left bank into the unprotected areas. So that's where the channel is widening. So the slide while I've been talking has, lists some of the really the 7 recommendations for this reach, and I could read through them, but I assume that you've had time to read them while I'm talking, and you also will have access to the plan very soon. For the Meadowbrook Slough Reach, the river is highly constrained in this reach, with 37% of the banks being hardened. So these red lines here indicate bank armoring, and you can just see how much of the river has bank armoring. And this is just a small snapshot even of the Meadowbrook Slough Reach, or not a small snapshot, but not the entirety of it. A lot of bank armoring. There's the elevated rails to trails trail, the Snoqualmie Valley Trail, that goes through here. It bisects Meadowbrook Slough and crosses the river via an old railroad trestle that ends in a set of stairs. We also identified that this portion of the river where the Snoqualmie Valley Trail crosses, it's a pinch point in the river system. All of the entire river has to flow through this one small spot, which is at least part of the reason that there's chronic problems with flooding and other issues on the other side, is this pinch point here. And pinch points in a river system, a dynamic river system, end up creating lots of problems upstream and downstream that kind of have to be chased around. And that's part of what this plan is intended to help create a more cohesive strategy to alleviate that sort of whack-a-mole approach and create something that's more sustainable in the long run. So floodplain features throughout this reach indicate that it was historically much more dynamic than it is currently. And the channel widening that has occurred over a small portion of the reach, that supports this historical pattern. The riparian forest and shading throughout this part are sparse on the south side of the channel, and the Meadowbrook Slough is almost entirely unforested. So again, our recommendations, since we found so much hardening constraining this reach, some of the top ones include removing the obsolete riprap and groins. This is an attempt to restore floodplain processes, right? And those are the types of things that we've highlighted, along with a lot of riparian vegetation help. And that's something that is common throughout the plan, is that the riparian forest is in pretty poor shape, unfortunately. For the city reach, the main stem upper Snoqualmie River throughout this reach is locked into place because of hardened banks, and the river is constrained in between this infrastructure. And as a result of this channelization, the river is vertically disconnected from its floodplain due to its relative depth. So throughout the city reach here, the floodplain is up here, the river is down here, and the river rarely can access its floodplain, much more rarely than it would in a more natural system. We found that gravels are uncommon in this reach because sediment transport dynamics suggest that most of the coarse-grained river sediment is deposited in upstream reaches, and that channel migration rates capable of recruiting local sediment sources are low due to the almost continuous extent of left bank protection and low gradient. Also here, the river is only capable of transporting sediments that include small gravels and sand, like less than 16 millimeters diameter during 1 year flows. There's an indication that gravels are coarsening towards the downstream end of the reach near the falls. This is likely sourced from bank sources downstream of Sandy Cove Park and is due to channel and slope adjustments related to engineered widening and lowering of the weir at the falls. So the city reach here is strongly gaining from groundwater. So groundwater gradients point across the valley and toward the river. And this results in lower stream temperatures from the addition of colder groundwater, despite extensive clearing of the South Bank riparian forest. So we found that August stream temperature is 2 to 3 degrees Celsius lower in the city reach than temperatures in the Middle Fork Snoqualmie. And it's a 0.5 to 1 degree Celsius lower than the temperature in the main stem Snoqualmie up at the confluence of the South Fork. So the recommendations for this reach include, there's a range of high impact to low impact and high cost to low cost. Relocating the power lines and converting to forested buffer. That's one of the ones on the higher end. If they can't be moved, where the power line corridor is just a homogeneous blackberry acreage, can we convert that to a native shrub community and plant trees along the riverbank where the power lines cross the river? Those are some of the types of suggestions, and not to be dismissed in any way. The need to improve tribal access to both the top and the bottom of Snoqualmie Falls is something that we wanted to highlight in this plan, and something that our data indicated there's a real need for. For the Kimball Creek Reach, this reach, it includes Kimball Creek and the surrounding floodplain wetlands and water bodies. They drain an approximately 8.7 square mile area in the Snoqualmie River watershed. We determined Kimball Creek flowing through 3 different land use zones. They include low gradient, flat agricultural or formerly agricultural wetlands at the downstream end, and intermediate gradient, slightly steeper urbanized areas through the city of Snoqualmie, and then steeper forested sections at the headwaters, much of which is owned by the Department of Natural Resources and King County Parks. The creek channel was dredged up until the 1960s by the now defunct Kimball Creek Flood District, and that resulted in a deep channel morphology throughout the urbanized section. So the banks are very steep and the channel is deeper than it would be otherwise normally. Kimball Creek has impaired water quality with very high summer temperatures, greater than 18 or 20 degrees Celsius commonly, low dissolved oxygen, and signs of pollutants from roadways. as well as the upstream casino detention pond. So recommendations for this reach include, you know, again, more riparian reforestation, stream restoration in the previously dredged section, like regrading the oversteepened banks and placing wood in the stream to add complexity and to help retain the gravels that are naturally being recruited from Coal Creek and Fisher Creek. And those, you know, it turns out actually the tribe has a restoration program and has been able to work with a few landowners through this reach. And we have a template actually of success in regrading banks and restoring the native plant community to the creek through there. So there's a lot of success already on that's been done there. And then if not already implemented, we recommend using BMP's, best management practices, at the casino detention pond and an application of road salts to help mitigate any water quality impacts that are occurring through this reach. Overall, it's abundantly clear that the project area needs a comprehensive forest stewardship and management plan. Forest health will continue to decline without interventions. And as we go forward with that and start to consider feasibility for other projects as proposed in the plan, we should conduct a climate change and flood risk analysis to protect infrastructure and our future investments. You know, one of the projects on the higher end of the cost range of our recommendations has to do with the mill pond. Cleaning up the mill pond was going to require a lot of resources, and it's going to have a high impact. We found that increased river connectivity to the mill pond may help with erosion issues, quote unquote issues, in the city reach of the Snoqualmie River. But under current conditions, any river restoration actions that would increase connectivity to the mill pond would also increase the risk of contaminants to the river, which is not something that can happen. So the only real solution is to clean up the mill pond. It's going to take a long time, and it's going to be very expensive. And we feel like that's an argument that it needs to happen sooner than later. It's the right time for this plan to be published and to continue this work and push our region to change the conversation from short-term or, you know, what ends up becoming emergency fixes to rebuilding the inherent resilience of the river and the surrounding community that relies on it and appreciates it. And so our next steps, or really kind of our current steps, are holding community meetings with our stakeholders and interested parties like we're doing here. We met with the city of North Bend and the city of Snoqualmie and King County earlier. And we're planning on publishing the Resilient River Corridor Management Plan very imminently. We're just putting sort of the very final aesthetic touches on it and final design. It's essentially finished, so that will be available very soon. And we really look forward to identifying opportunities to collaborate on resilient river actions and ultimately to implement them. And that is the end of my presentation. And if there are questions, I'm happy to try to answer them.
Great. I mean, I can't wait so I can read every bit of it. And I just learned an awful lot about, just from the picture presentations, about the river that I did not know. Yes, some of it's technical, but not that it's so technical it's not understandable. And the questions in chat, as well with any that you wish, Karosh, our technical guru, will handle that for you, because I only have one screen. So, and I managed to get back on because somehow I got pushed off in between this presentation and getting ready for the end. So please ask your questions, Matt, and on chat, and Karosh will conduct a coordination of that. And at
Yeah,
the
I don't think there are any questions in chat, so fire away.
Yeah, please unmute yourself if you have a question and ask Matt, our very, very knowledgeable speaker. I'm sure there's lots of questions about this presentation. I have one. Um, Matt, what can we do as residents of this area to kind of support the decision makers in accepting and implementing these recommendations? These are clearly the outcome of a lot of research, of talking with the community and finding out what they need, and so they seem to make a lot of sense. What can we do to support our decision makers to accept them and to carry them forward?
Yeah, I think that sort of the normal avenues for civic involvement are probably the most obvious ways. I think that it begins with this sort of outreach and awareness, and so that concerned citizens are aware of this work, as well as building hopefully a common understanding of really the diversity of community desires for the river, and communicating that to your elected and officials and city staff when you have the chance to do so. I think that the city of Snoqualmie is of course doing their planning processes for the river shoreline, whether it's mill site planning or river walk planning, or those types of related things. And I think that this is sort of an attempt to tell the tribe's story, as well as the feedback that the tribe heard in our efforts to hear from the community. And I think that there are other processes and avenues where interested citizens and community members can communicate to those decision makers. So I'm also open to those ideas, and would love to learn from you all what you think that you can do as well, because I imagine that there are many that I'm not even aware of.
Donna?
Matt, one of the questions I have is when you spoke of the different reaches, so are these areas basically controlled by the city or county in each section? So you have to coordinate all of those together to get the whole river to be managed?
Yeah, to some degree. So yeah, I hadn't thought about where the bound. So the city of Snoqualmie jurisdiction goes to, I think, about Meadowbrook, or maybe a little bit upstream from there. And so, yes, there does need to be coordination between what's happening in unincorporated King County, as what with that, and then how that affects what's happening downstream in the city. And so that's kind of what we were saying, is that, like, the things that have been happening around Snoqualmie Falls and throughout the city, the way a river system works changes down there actually cause changes that far upstream. And you know, we present evidence to that in the plan, and cite references to why we think that that's occurring. And you know, it's not just the tribe that has made that conclusion. So it does take a lot of, it does, that's kind of you know, the main impetus for this plan, is that what we were seeing was that, you know, the right hand may not know what the left hand was doing, due to the sort of artificial boundaries of city versus county jurisdiction. And really, you know, even the city of North Bend has a role through this too, given their jurisdiction over the South Fork and Middle Fork as well, and their role to play with the Meadowbrook and the management of Meadowbrook area. And so, you know, that's why we wanted to bring the plan to both the city of Snoqualmie and the city of North Bend, and then King County as well. But in terms of the actual, like, where, you know, the legal jurisdiction or whatever, our area really just encompasses King County from Three Forks and then on down through the city.
Thank you.
Mary.
Yeah, I live in Falls City, and we just went through what they say is a 50-year flood, or that happens only once every 50 years, the one that happened 2 or 3 weeks ago. As you were describing, hard sides to the river, and that it wasn't reaching the floodplain. My question is, if that's resolved and the waters can access the floodplain, will that change the severity of the flooding downstream, like in the lower Snoqualmie Valley?
In a very simple way, yes. I mean, the simple answer is yes. The complication is that there are a lot of other factors across an entire watershed, including what's going on downstream, you know, how heavy precipitation is at certain parts of the basin at certain times. Like, if you look at, and as a Falls City resident, you're likely well acquainted, at least some of the Falls City residents and Lower Valley residents I know are well acquainted with the river flow gauges, and watching those as, you know, floods are occurring and receding. And they are, you know, every flood sort of acts differently. And my understanding, you know, a lot of that has to do with the sort of rates of precipitation that are variable across different parts of the watershed. And as you know, if water is really high lower down, and then it kind of tries to come down and it's already high, you can get a worse flood because the existing water is like backing it up like a dam. And so these things are so dynamic that it's really hard to say yes, but in the most simple way, yeah, absolutely. More flood storage in the upper part of the basin can alleviate to some degree the flooding lower down. That can be through a timing thing. It might be the severity, you know, it's hard to say exactly because every storm and flood is different. But yes, yes. And so, you know, the other thing about the bank hardening that's there's sort of these feedback loops in the natural river system with the way the river system works in conjunction with the floodplain, the riparian floodplain forest, and the alluvial aquifer. And so the alluvial aquifer is just, it's that portion of groundwater that is generally contained within what we call alluvial sediments. Alluvial just means river related, essentially. And so those sediments are, gravels, cobbles, sand, maybe boulders, but those types of coarser sediments. And those have a lot of capacity to hold a lot of water and to transmit water. And so they're generally connected to the river, and they're laid down across the floodplain over time through natural river shifting and, after recession of the glaciers. And so when you harden the banks of a river and when you disconnect it from its floodplain, it's also disconnecting it from the alluvial aquifer, because those floods are, part of the chance for the river to reach all the nooks and crannies and all those oxbows, like in my background here behind me, that are connected to the river through its historic migration patterns. And not only, does the floodplain give more area for the floods to spread out, which makes it shallower. I mean, it's just, that's just how it works. But then, after floodwaters recede, that's like a reservoir for that water, and it will stay there for quite a while and then can be slowly released back to the river in a way that's really beneficial for the environment. And really beneficial for ecology, because it kind of helps to stabilize stream temperatures. When the river's really cold, groundwater is warmer than the river, and so groundwater inputs are kind of helping to buffer that, which is good for fish and other organisms, because it's warmer water is more productive at that time. Cold, they just kind of have to shut down. In the summertime, groundwater is cooler than the surface water. And this is really, really important, especially in the Snoqualmie, we're finding out, is that groundwater is, and that alluvial aquifer is, and what we call hyporheic exchange, which is sort of water as it flows down through the river system doesn't necessarily just stay in the channel. Like if I'm a molecule of water and I'm going down the river from, I'm in the Middle Fork, I'm in the Pratt, I'm way up there, right? And I'm a molecule of water and I'm happily going down the river, and I'm hitting rocks and I'm in the river. And then I come to a big old log jam. Can't even think of where a big log jam is right now. There's some in the Taylor, few in the lower Pratt. And I have to slow down because of this log jam. And so I'm bouncing around in some eddy and eventually get pushed into the bank, right? And with some of my buddies. And then I'm in the alluvial aquifer. Well, maybe it's a really coarse bank, and I'm just there for a short while. I cool down a little bit from surface water temperature, and then I enter back into the river a couple hours later. I could enter back into the river a couple hours later. I could enter back into the river 24 hours later, 48 hours later, 3 months later. And when you see the diagrams of how this works, and this has been studied through like isotopes and dye tests and everything, they'll have like the river, and then there's like different loops, and there's like a shallow one, and they'll have a time, and then there's a longer one, and then there's a longer one. Or if you think of it on a like a plan view, if this is the river going this way, and here's my molecule going just a little bit over, here's my molecule of water going a long way over, and then 3 months later it comes back to the river. And so 3 months later, if I'm a molecule of water that came down in June in runoff, let's say we had a good snowpack and water's still running off at the end of June, heavy, and I'm there in the bank for 3 months, and I come back in late August, or when it's just, the river is just bony low and getting really kind of warm, and that's also when the Chinook are starting to come back and starting to stage for spawning, that's great. And that's what has been lost across our landscape, is that ability, that complexity of the river. You know, the river, really rivers across the Western United States, but the Snoqualmie River is one of them, have been straightened. The riparian forests were cleared. There are logs. Log rafts were sent down the river. You know, snags. There were groups. I wish I had this slide. There were boats, steamboats sent up and down the river to pull snags out for years and years, so that the people could go up and down the river. I mean, the Snoqualmie River was hard to travel initially. That's why the Snoqualmie people used canoes, right? And because that was the most efficient mode of transportation. And so, because it was a complex channel, and that was really healthy for the river environment because of all of these tortuous pathways for water to go. And that is really what we're talking about, is that's what builds the resiliency. It helps to buffer the high flows, and it helps to buffer the low flows, and it helps to, and so those are the types of really most of these actions, the sort of on the ground actions about rebuilding the forest health and removing impediments to those river processes are focused around those kinds of concepts. Laura.
You mute.
Laura, go ahead, Laura.
Sorry. Really interesting. I was curious, you mentioned that you were maybe surprised to find how groundwater coming in at certain places actually helped to improve the water temperature. And I was wondering if you did any analysis of what the environment was uphill of it, or like, are there, because I always think of like, oh, the riparian edge is where everything has to happen, but maybe it's if you're thinking about the groundwater, maybe are there things that people could do? I don't know, like where was the groundwater like really helping the river? And maybe that is an indicator of, maybe encouraging people to plant certain things, or I don't know, just other types of stuff. If you're a land manager who's not like directly on the river, but
Sure.
you wanna somehow think about the whole valley. I'm just curious if you found any correlation between where groundwater was helping. And I'm guessing that's also something where water sits and it sort of slowly percolates in. Maybe I'm just curious if.
I think anything that people can do on their properties, whether it's upland or lowland, to help restore and mimic the landscape's natural ability to absorb and then release water in a more slow and controlled manner. I think anything along those lines is beneficial. So, maybe you're nowhere near the river. Well, rain gardens, as opposed to, stormwater, regular stormwater management, putting it in a ditch. Those types of things are great. And that's, those are the types of things that can really help to mimic those functions of a watershed-wide forest that can be lost due to impervious surfaces from roofs and driveways and roads and whatnot. So yeah, rain gardens are great. Just I think the buzzword now is green stormwater infrastructure, GSI, which is kind of rain gardens are like one portion of that. And so yeah, is that kind of what you're talking about? And then as for what can you do, like focusing in on where groundwater is gaining or losing, I think that, you know, it might be a mistake to sort of focus in on like, oh, you know, groundwater is gaining here, even though the riparian buffer is kind of, you know, crummy. So it's fine, you know, we can just go with that. And then, you know, over here is really where we need to focus on the riparian buffer. That's not exactly, you know, that's, I can see where, you know, one might be tempted to think like that, but that's not exactly where I would go. I mean, so the riparian buffer serves a whole lot of different functions aside from just shading, although shade, so the way, I guess, you know, so through the city reach is where it's, the river is cooling down in spite of there being really not much of a buffer, right?
Interesting.
And that's because groundwaters come in to cool it down. Well, if there were a buffer, I mean, just because it's cooling from that groundwater doesn't mean that warming isn't still occurring at the same time. It just happens to that the degree of cooling is enough that it's like swamping that all, you know, whatever warming is occurring. So the warming is still occurring because, you know, when here my molecule of water is going down river, like as long as incident light is getting onto me, or as long as ambient temperature is warmer than the water, the way thermodynamics work, the water is always going to be approaching that, you know, we're going to be warming. And so it's still going to be warming. It's, you know, I encounter a cooler spot of the river because I've got a bunch of cool groundwater buddies, and that's going to help cool me down all of a sudden. But if we can lessen that, you know, increase the shading and lessen the incident light hitting the river, that's great for the summertime, which, you know, in the Snoqualmie we really have warm temperatures in the summer.
Yeah.
So there's other functions of the buffer though too, which I didn't really talk about too much. So you know, when you're talking about like bank hardening and river migration processes, so large trees play a really key role in channel dynamics. And so, you know, without wood in the river, you kind of, it's in this sort of intermediate state right now. There's a little bit of wood in the river, but it's a pretty clean channel, and, you know, it's got pretty straight banks and, you know, fairly clean. And there's not a whole lot of islands or side channels or, you know, big bends or tortuosity or complexity like that. And in Pacific Northwest rivers, large wood plays a huge role in creating that complexity. It helps to retain gravels. So, you know, if you've got quote unquote erosion issues, having a lot of large wood around can help that. You know, large wood can slow water down. And so if flooding nearby is a concern, then you know, anything that slows water down, you have to figure out how you're going to address you know, floodwaters created by that. So there's a balance to be found between the habitat complexity that we need and all the good things that wood does, with the fact that we're constrained with all this infrastructure around us. And, you know, we have this flood regulatory component, and, you know, we can't increase flood risk. And so it's really tricky. There's just so many constraints in this throughout this reach. It's like there's almost no room to breathe for the river. And so that's why we're saying, you know, we need to think big here. We need to come up with a long-term plan with the community, because it's not going to be able to be done by the tribe alone, and it's not going to be able to be done by the city alone. It has to be done with the will of the community and the tribe and the city and everyone involved. And to, you know, how are we going to create a resilient river that's going to work for everybody in the future? Because, you know, climate change is indicating that you know, we're going to have more frequent big rainfall events in the fall and more drought in the summer. And so we've already done, you know, society has done a lot of things to the watershed to decrease the inherent resiliency that was once here. So we can do some things to help fix that, and that will help to buffer against the impacts of climate change. And other things that are really helpful watershed wide along those lines include beaver. Presence of beaver in the watershed are excellent, and beaver can be annoying to people when they're doing flooding things that are on your property, but beaver in the headwaters are amazing for buffering floodwaters and big rainstorm events. They create natural flood storage, and they do all these functions that I've been talking about pushing groundwater into the floodplain to slowly be released into the channel. And there's a lot of work that's been done, a lot of studies showing all the stream and aquatic habitat benefits of having beaver in the watershed.
Well, Matt, I am so excited that you have so much to share. I mean, we could have you back because I can tell you're passionate about your study as well as your knowledge. And I am enthralled and looking forward to talking with you more about this subject. But we've gone to an hour now, 8:07, and I know you have children at home from swimming, and you'd like to have dinner with them as well. So, are there any other questions that we could have him answer quickly? Thank you.
I have one quick question. I'm curious to know what the area that we now call Snoqualmie Falls, what did that look like 1,000 years ago?
Well, I wasn't here, so I don't know.
But you're the scientist. I mean, was it always a falls, or is that something that is a result of the power plant there, or what did that look like before people tampered with it?
It's a natural falls. I think the falls look substantially similar to how they have for a long, long time, other than perhaps the flow rate over the falls being changed due to manipulations for the power plant, and then of course the buildings that are in wires that are visible around it. But from what I've seen in the historic pictures, I mean, the falls look pretty much the same. There's the rock in the middle, the kind of double falls, and sometimes there's trees perched on that rock and stuck on it, and sometimes not. And I've just seen the same pictures y'all all have too from the Historic Society. I don't have any special access to anything. So, and yeah, I'm not a tribal member, like I mentioned. And so, I think that the tribe has said the tribe says that the falls were created when, I don't know, I can't say his Lashutsi name, but Beaver is the creator, and Beaver slapped his tail and created the falls. So that's how the falls were created.
Thank you, Matt.
It's a nice place to end it, Matt.
Yeah.
Matt, if people do have questions later, can they email you? I know you say you have a YouTube address to listen to this in even more detail.
Oh, there's a version of this presentation on YouTube that we edited down from another presentation just to have it out there. So that's available. Yeah, people can email me. I put my name in the chat. It's just or my email in the chat. It's just mattb@snoqualmietribe.us. And
okay, that's wonderful.
Yeah, and so like I said, we are super duper close to having this thing finalized. And so I have Mary and Charlotte's emails, and I'd be happy to send a link out when everything is all published. But we'll put an announcement out on social media channels, and so if you're tuned into that for the tribe, then it'll come through those channels as well. So, but I'll make sure to reach out to my contacts with your group and stuff, and make sure it's out there. But hey, thank y'all so much for this opportunity and your questions, and yeah, I really appreciate it. Thank you.
We have another Zoom next month. It will be on the 25th, April 25th. Shay from Oxbow will be talking.
Oh, yeah.
He's going to speak around the youth involvement in working with the environment around the river, and what and learning a little more about the environment around the river. So please tune in, everyone, including you, Matt, if you wish. So again, thank you all for such giving up your precious time. You, Matt, from your family, and everyone else for having the interest to listen to our series on climate change and the river in our backyard. So thanks again, Matt.
Yep. Good night, everybody. Take care.
Good night. Bye.